Welcome back to Nick Does Maths. Welcome here. We are going to do some maths, a nice integral, and we have a little discussion about where our mind goes when attempting something like this. Now, personally, first time I tried this integral, here's where I went. Well, I've got like this weird 2 minus tan x. I'm going for the Weierstrass or the t substitution. So that is t is tan of x over 2. Now, this does give me these identities, which we can derive, but that is not the point of today. And tan x is 2t over 1 minus t squared. So my integral then becomes, when x is 0, I get t is 0. When x is pi over 4, I get tan of pi over 2, which is infinity. Now that's already ringing alarm bells. And we end up 2 minus 2t over 1 minus t squared times 2 over 1 plus t squared dt. And at this point, I'm not so happy about what's going on. All right, already at this point, I'm not so happy. I've got some weird stuff going on here that I could try and deal with, bring that up there. It looks like a mess. So I was trying to be too clever. But that might be where you go thinking about this as well. And sometimes in maths, it's okay to go down the wrong path. All right? It's only by doing that that we'll figure out what we can do. However, there were some interesting things going on there. So maybe I just simplify it a bit and I go u is equal to tan x. What if we just go u equals tan x? So end up with du is sec squared x dx. Well, that's 1 plus tan squared x dx, so it's 1 plus u squared. So we can do some nice stuff here. Now this is probably a little bit nicer as well because it keeps my limits a bit nicer. So if x is 0, u is 0. When x is pi over 4, tan of pi over 4 is 1. 10 over, this is much nicer, 2 minus u. And I will end up with du over 1 plus u squared. Now, I'm still not feeling hyper confident about this, but actually, all we need to do is a little bit of partial fractions. So we'll go something over 2 minus u, and then, because that's quadratic, I need something linear up there. Okay, so let's do our partial fractions. Let's go u equals 2. U go away, so that tells me that a is equal to 2. And then it's sort of up to us. If I go, I knew I was going to do that. There you go. How many of you spotted that straight away? I'm going to go u is 0 plus 2c. C is 4. And then, let's pick one. Let's go u is 1. U is 1 is normally quite good. We get 10 is 2a plus b plus c, because 2 minus 1 is 1. So that's 4, that's 4. That will give me b equals 2. So the integral that we want to do becomes the integral of 2 over 2 minus u plus 2u plus 4 over 1 plus u squared. So that makes sense to me? Feels like it makes sense to me. So that is the integral we now want. Which is kind of useful, actually, because it is an eminently doable integral. Because what we're going to do is, once I remember to put my du in, is we're going to split it up even further. 2 minus u is all good. 2u over 1 plus u squared, I quite like. 4 over 1 plus u squared I also quite like. Now why do I like this one is because 2u is the derivative of 1 plus u squared, right? 2u is the derivative of 1 plus u squared. So we are ready to rock and roll. What do we end up? That is minus 2 ln of 2 minus u plus ln of 1 plus u squared plus 4 arctan u. Now what does that give me? We could actually tidy this up a little bit into 1 plus u squared over 2 minus u all squared plus 4 arctan u. So let's put 1 in. What do we end up? Ln of 2 over 1. We get ln 2 plus 4 times arctan of 1 is pi over 4 minus, let's put 0 in, ln of a quarter, and then arctan of 0 is 0. So this is going to become ln 8 plus pi, also known as 3 ln 2 plus pi. Rules of lns, y'all. 2 divided by a quarter is 8. Very nice. So, a much simpler substitution. We still had some weird partial fractions to do, but nowhere near as bad. But don't be afraid to try your first guess and see where it goes. And sometimes you just have to go back and try something else. Beautiful. Right. Please don't forget to like, subscribe, hit the notification bell. Drop us a comment. Is there another way that you can think of to approach this integral? Let me know. Have I missed something? Don't know. 'Twas me, Nick. I did some maths. And I will see you next time right here on YouTube for more big, lovely questions. See ya.